Go for 13. Now this is given A, this is given B, this is given C. Be the three matrices A, B, C belongs to R. Trace of AB. AB, you understand trace? Trace means sum of the diagonal elements. Trace of C is this, sum of these diagonal elements. This should be equal, where trace of A denotes the trace of A, and Fx is given by this. Find the value of F1. Means I want to know A plus B plus C value, right? So nothing, you just have to multiply them. AB. Have you done this question? I think it is a mechanical question. I think you can easily handle. 3x square A, first term, right? Second becomes B. X square B, then you have 3x square C, then you have A, B, C, then you have 6xa, 6xb and 6xc is your matrix AB. The trace they are talking about, the trace is this value. 3x square A plus B plus 6 times xc is your trace of AB. It should be equal to trace of C. What is trace of C? X plus 2 square, 2x plus 5x square. Nothing, just you have to compare x square coefficient, x coefficient and constant term. You will get A, B and C, and sum of that is your final answer. I think you can do that. You want me to tell the answer? I don't think so. The answer I have. Answer is, I guess, 7. 7 is the answer. Can you go ahead? You understood now what I did? Just expand it, compare it. You'll get the answer. 14th question. These are the 2 points on these planes. Okay, as is being seen also. Respectively, C is a variable point lying on both the planes. On both the planes, a point is lying C. Okay. Means it will lie on their intersection or line of intersection, such that the perimeter of triangle ABC is minimum. Find the point C. So it is the question of calculus, I guess. You understand? These 2 points keep aside. First of all, get the line of intersection. To get the line of intersection, you have 1, 1, 1. I am calculating the cross product, means dias of line of intersection. You know that? The cross product of the dias of this normal. So to get this, it's easy. I minus 1 plus 1 becomes 0. Minus j minus 1 minus 2 minus 3 plus k minus 1 minus 2 minus 3. You got 3j minus 3k is the dias of the normal or dias of the line of intersection. Now to get a particular point on this, you take any one of that point also, it is not a problem. Common point I want. X plus y plus z equals 1. 2x minus y minus z equals 5. You take x as 0 or y as 0. Take y as 0 and add them up. 3x equals 6, x equal to 2. Put x is equal to 2, y is 0, that becomes minus 1. So you got this point on line of intersection. The equation of line becomes x minus 2, y, z minus minus plus 1 over 0, 3 and minus 3. I can remove 3 also. This is the equation of line of intersection. Okay. We need to take a point on this line. Let us take it at lambda. So x becomes 2, y becomes lambda, and z becomes minus lambda minus 1. So C point obtained as 2 lambda minus 1. A and B are with you. A and B are with you. So this is the triangle formed. Its perimeter should be minimum. You see that. What do you have to do? You have to do the distance, and that distance assume it as d. It is in terms of lambda. Calculate dd by d lambda, equate to 0, find maximum minima and get the value of lambda. You understood? Shall we proceed? Next question is your matrix. A set A is a set containing n elements and P is a subset of A chosen at random. And the set A is reconstructed by replacing the elements of P. Another Q subset is being formed. This we have done number of times. This question is very easy. You take it that element is, let us suppose, AI, and the possibility that it goes in P and Q both. It is present in P and Q both, or we write it like this. Present in P, not in Q. Present in Q, not in P. Present in P, present in Q. Present in neither of them. Any random element AI I am talking about, which is the n contained element in set A. You understand what I am saying? A1, A2 up to AN, let us suppose, are the elements in set A. I take it a random element AI and tell you the status that where could the possibility of that element to go. It can go in P but not in Q. It can be present in P, not P, but in Q. It could be present in both, or it could not be present in both the two sets, subsets being formed. So there are 4 possibilities. There are 4 possibilities for any element to move on, to go in any kind of this cases. The 4 possibilities which are made. What they are saying now, they are giving the question that P union Q contains exactly R elements. P union Q should have R elements. What do you say? Exactly R elements in this. So when you do union of them, some elements should be it should not be it cannot form R if the element is not present in them. Either this way or this way or this way. Isn't it? These are the 3 possibilities the element can move. These are the 3 possibilities to make union as R elements. The 3 possibilities are there to contain R elements. R elements to be taken from that is NCR ways. Okay? NCR ways, selecting of R elements from the given n elements. Each element should be either here or here or here. So 3 power R is the support for that. 4 power N is the total sample space. Possibility of each element to go. Every element has 4 possibilities, na? This way, this way, this way, or this way. So denominator goes with 4 power N. NCR is the number of ways of selecting exactly R elements. And 3 power R will go here, in which the element can be taken in union wise R elements. So this R is the answer for first. Second is at least one element, means total possible minus no element. I think the answer is pretty clear, is this, isn't it? So this is over. P intersection Q contains exactly one element. So P intersection Q is this, in which common is there. It should contain exactly one element. So that an element, out of that one element goes in this, and remaining element should go in all the three possibility cases, this way, or this way. Answer is this. P intersection contains no element, means in this there should not be any element, all elements should go in remaining three. So 3 by power n upon 4 power n. Understood what I said? This type of question can come for, instead of 2 sets, they will make 3 sets also. I'm telling you an extra part. This question can come for, instead of 2 sets, for 3 sets also. They may make P, Q and R. So when you make the possibilities, in that case, there would be 8 possibilities. You understand? Out of 8, there is only one in which the element is present in all the 3. And 7 possibilities are the other ones. So if the question comes is like this, P intersection Q intersection R should contain exactly 2 elements, for example. So your NC2 will come in that case. I'm writing the answer for it. NC2 for 3 set game. NC2, the element goes in this common portion. Remaining 7 possibility, remaining element goes 7 power n minus 2. And denominator, every element has 8 possibilities, so 8 power n will come in this. This is another kind of question which I made it, instead of 2 subsets, I made it 3 subsets. Am I clear?